Cool! Today, it's a special day. We're taking out from the archives the first ever script I've written in Haskell. The code sucks, but there's a couple of things that I believe are really interesting. So without further ado, let's jump in and take a look at those tidbits. Okay, again, we're not going to take a look at the entire script. There's a link in the description if you're interested. But the idea here was that I'm on a macOS and I needed to reinstall the operative system. I needed to migrate to another computer. Now, on macOS, there's this package manager called Homebrew, and it allows to create what is called the brew file. So you could dump potentially all of the installed packages and apps into a brew file, and then on the new machine, with a super simple command, reinstall everything that was installed previously on the other machine. What I wanted to do here was that first I wanted to create the brew file using the homebrew dump command. And then I wanted to add to that brew file all of the apps that maybe I installed through the App Store or downloaded manually, but that I could have installed via Homebrew. And by creating this brew file that contained all of the things that I already installed via Homebrew and all of the stuff that I could have installed via Homebrew, then I would have, let's say, automated more work, and I would have had to install less on the new machine. Okay, but those are just details. Let's get to the meat of the script. So we first check if the file brew file exists in the current directory. If it exists, we exit with exit code 1 and we print to standard error this string. Then we go and get all of the names of the installed apps on the operative system, and we go and check which apps could be installed with Homebrew. At this point, we take the intersection, which means we are going to take out of all of the apps that are installed on the operative system, what could be installed by Homebrew. And in the lingo, in the Homebrew lingo, those are called casks. Then we take all of the lines out of the file that Homebrew would generate by doing Homebrew dump. And since this returns IO of header, so we still need to do fmap to get inside of the header. Here we unionize all of the lines of the brew file dump with the casks that we found here. And then we either fail if the header that we got out of here was a left, or if it was a right, we would write the brew file and print a success message. The interesting part here, I guess, is this operator here, which I totally don't know what's the name of. If anybody knows, please write down in the comment. But I guess, like, I still remember trying to make this program compile, and I was throwing whatever operators I could to make this monadic composition happen. I guess I would write it in a different way if I had to rewrite from scratch the script. But still, it's interesting to know that this sort of stuff exists. Another piece here that could be interesting is this list directory. So this function here is in charge of returning the installed apps on the operative system. And what it does here is that it takes all of the files contained inside of the applications folder, and then it takes their base names. So I don't really know, I think it's .app, the extension of an app in macOS. So if there was, I don't know, Sublime Text.app, this take base name would extract Sublime Text. Finally, the last tidbit of this script. So I think this is really cool that from Haskell we can call a command line program by using read process, the name of the program, and then the argument we want to pass. The idea here is that we call brew bundle dump, asking it to print the dump to standard output. And then we can capture the output and do whatever we want with that. This is, I think, really a really cool thing to do. What I can say is that, well, first of all, I suck at Bash. So had I written this script in Bash, it would have been a disaster for sure. So maybe if somebody knows how to write scripts better, disadvantages would be, let's say, a bit mitigated. But the point is that now that I have this script, it's really easy for me to understand, because looking at the types and the way that Haskell kind of forced me to organize code made it super clear. Even if, again, it's not the best Haskell I could have written, of course. It was one of the first thing I've done. And the second one is that if I wanted to, refactoring this script would be incredibly easy. And of course, it's because of the types and because of the compiler and because of all of the nice things that we are used to in Haskell. Well, in any case, this is it for today. I just wanted to say thanks for the comments, thanks for the support, and thanks for the subscriptions. I really appreciate that. It keeps me going. And I'll see you next time.